Hello everybody, thank you for joining me once again. We're looking at the 2004 Pascal paper, and we're on question number 14. How many unshaded squares are there in the 10th figure of this pattern? Okay. So, what we could do is either start counting out the number of squares and see if we can notice a pattern, although there's only 3 of the figures to work out. Or we could make an observation. This is a big square with a smaller black square removed. So we can think of it as sort of the first figure is a 3x3 grid with a 1x1 square removed. And the second one is a 4x4 grid with a 2x2 grid removed. And the next one's a 5x5 grid with a 3x3 grid removed. And so this is sort of how I like to generally set up these. It's more common to have this as a sort of find the area of this shaded region style question, but this works exactly the same. What are the things we want? We want the unshaded squares. How can we achieve those? We can figure out how many are in the big grid, and then figure out how many are in the smaller blackened out grid that we're removing. And what will be left is the number of unshaded or white squares. Okay, and then we figure out the pattern and we apply it to the 10th figure. Okay. So let's grab our notepad. We're going to draw these out and at least figure out a little bit what's going on. So we draw a 3x3 grid and we subtract the 1x1. So a 3x3, it has 9 of these squares, and we subtract off a 1x1, and that leaves us with 8 left over, and that's figure 1. Okay, so note for figure 1, we are dealing with a 1x1 being subtracted from a 3x3, which is 2 more. Alright, so now figure 2 will have a 4x4 grid, and we're subtracting off a 2x2 grid out of the middle. So this is a 4x4, so 4 times 4, there's 16 squares there. Don't believe me, you can add them up. And we're getting rid of a 2x2 grid containing 4 squares, and that gives us 12 squares remaining. And that was figure 2. So once again, figure 2, and then what's changed? We have 2x2s and 4x4s. Okay, we could go one step further, although hopefully most people out there are seeing the patterns. 1, 2, 3, 4. 1, 2, 3, 4. Doesn't have to be exact. So now we have a 5x5, which has 25 squares, and a 3x3, and that leaves us with 2, 3, 4, 2, 3, 4. 25 minus 9 is 16. Okay, and that's figure 3. Alright, so we can either take note of the pattern that we're seeing. It's going 8, then 12, then 16. It's going up by 4s. So what we could do is draw the next one in the pattern, figure number 4. That'll be a 6x6 grid with the middle 4x4 grid removed. And we should expect to see 20 squares. And that would confirm our hypothesis. Or another thing we could do is realize, okay, figure K is going to be a k plus 2 grid times k plus 2 by k plus 2 grid minus a k by k grid. Just like we had a 1 plus 2 times 1 by 1 plus 2, 3 by 3, minus a 1 by 1 for figure 1. And we had a 2 plus 2 by 2 plus 2, so 4 by 4 grid, minus a 2 by 2 grid for figure 2. Okay, so either way we do it, that's fine. So I'll sort of make note of both patterns. Do I have the blue? Yes, I do. So we can either recognize that for figure 1, we've got 8, 2, we've got 12, 3, we've got 16. We'd predict 4 with 20, and we'd work that out. And then we'd say, okay, what's the pattern? Well, it's sort of, this is 4 times 2. This is 4 times 3. This is 4 times 4. We take the figure number, add 1, and multiply it by 4. So what would happen on the 10th figure? 4 times 11, and that would be 44. Okay? Or we could realize that in general, figure K is a K plus 2 by K plus 2 grid, and that has how many squares in it? K plus 2 squared. And we would subtract off a smaller K by K grid, which has K squared squares, and we'd be able to work that out as well. And so this is K squared plus 4K plus 4 minus K squared. So that's going to be 4K plus 4. Or hey, look at that, we've got 4K plus 1 again. And so that would go and give us 44 again. So there's two ways we can get 44. The technical, mathy, using polynomials to prove what we're doing. But of course that's not necessary. We don't have to prove anything. This is the multiple choice contest. Just get your answer and bubble it in. Or we can just recognize the pattern. Now either way you do it, what I would suggest, and I didn't do it here, although I wish I had, just so that I can look like I'm good at doing contests, what you should have done is said, okay, I predict the fourth figure will have 20 unshaded squares. Let's draw that out. I understand how to make these new figures, but I just want to double check, am I seeing the right pattern? Am I extending it in the right way? It's a good thing to do. Now, it probably wasn't that hard for this question. It's a grade 9 contest, grade 9 question. But if you keep going with these and do things like the Fermat, the pattern that you see might not be the one that actually extends. And so it's always a good idea to say, I predict it will be this for figure 5, and it'll be this when we smush 10 triangles together, or whatever it is. And check. Okay? That way you can tell whether or not you really get it, or whether or not you're seeing a different pattern than is actually evident. But enough jibber jabber. Let's go and take a look. Where is there? It is D44. D. And that was question 14, right? Yeah, question number 14. So we'll be doing question number 15 in the next video, and I hope you guys join me there. Give it a try before you get over to that video, and I'll see you there.